I'm working as a senior specialist of software architecture at Modular Management, and this is my first month. Previously, I've spent 22 years at ABB for software development. I finalized as the chief engineer of software products for AV Robotics. I held several roles in the past, and as you can see, I'm really a computer geek with barbecue and technology interests, and I also do a lot of interesting spirits. So the bucket on the image is actually when you do your own glögg in Sweden. Very interested in these different things. I also think that this is a pretty good quote of Niels Bohr back in the day, that an expert is a man who made all the mistakes which can be made in a narrow field, and that's basically really how I feel. I've done a lot of interesting mistakes and learned from them. Let's take a short recap of AV Robotics in case you're not aware. So ABB, pretty large company with a very long heritage, 130 years in the business, starting with education. But in recent years, more focusing on automation and the fourth industrial revolution. And robotics then, it's a part of, it's a division now in ABB organization, as you can see on the right-hand side. But there's 15 active divisions within ABB that is in Sweden then. AV Robotics actually started in two times, in Norway in 1969 with the first print robots, but also almost more known, the first electric robots 1974 here in Västerås. And since then, we have installed over 500,000 robots worldwide, and are located basically all across the globe. And what ABB does is basically a robot manipulator for every purpose, but also then the application that the robot is doing, as well as other process equipment. The key thing for this meeting is that all of these robot arms are controlled with one control system. So if we look at the future outlook for robots in general, I think you're all aware that we have a demographic time bomb in some countries where there's an aging population and we need to replace them. Also, robots provide more meaningful work for people. But also, I think that the entry barriers are going down. So previously, robots has been in automotive for a very long time, but now we're seeing that even small firms are deploying robots in a much higher rate, specifically in the collaborative workspace where you work side by side with the robot. So making it easier to install, and these robots are increasingly important. Previously, you could have like a full division that only did robot integration at these big automotive companies, but that's not the case if you look at the grocery store downtown. That really is not viable anymore. Also, the scaling factor is really where robotics come in, where you produce a lot of things. And this has been the case for a long time, but also now is the mass customization that we're seeing across the globe. So even if you don't have a high volume of a specific product, you have a customization possibility that makes the product really have a complex manufacturing in pretty large quantities in all of them, and you need to reprogram often. If you look at, for instance, the mobile phone world, they reprogram the robots every third month. And if you look at automotive, they previously did that every third year. So there is really a paradigm shift in usability for a robot in the entire life cycle. Also, what we're seeing is that the robots are becoming mobile, and this is just examples of things that ABB are showing. Mobile robots, both in electronics manufacturing, but also in service robotics, is increasing. And therefore you need to have a much higher rate of mobility, and the connectivity part is extremely important because you can't have wires hanging out of the robot. That makes no sense. So ABB is of course involved in a lot of these questions around these things. And as I already hinted, the user experience is shifting. So on the left-hand side, I mean, the user experience to do a spot welding is very different from this user experience to program a collaborative picking. In the leftmost case, you fence out the robots. It's a dangerous machine. It can for sure hurt you. And on the right-hand side, you are impatient. You should come close to the machine and you really want to touch it and help the robot to do the work. So if you look at a user experience, this is very, very different. And of course, user experience is a lot of it is solved in software. ABB, as basically all automotive companies, are connecting stuff. So connected robots is ongoing. Already hinted that ABB has somewhere close to 10,000 robots already connected. And that will, of course, not decrease. It's going to increase. And paving way for digitalization and what you can do is something that ABB is focusing on. So that was a short intro to what ABB is doing. And I think I left ABB for a month ago, but I don't think it has changed so much since then. So if we look at the software then in an ABB robot controller, let's start from where it was born. So RobotWare 0.1 was the first version of the current generation of software. It was first released 1994, but actually development started in 92. And this was the first time ABB was using the new C language to program the machine. And there was a bit of Fortran in there too. The previous generations used assembly language, and so the productivity was much greater. And this one also had a teach-pendant unit, which was terminal-based with a black and white screen and a joystick, and you can see it laying on top of the robot controller here. So this was a state-of-the-art machine with distributed computing, extra networking, an IO computer, state-of-the-art for 1994. But as you can see, you booted it with 3 diskettes and you had like a battery backup for RAM storage. Fast forward then to what we have today. The OmniCore controller family was first released 2019. And the CPU performance is greatly increased, as you might spot. The development languages has improved pretty greatly. And now basically all the boards that we had previously have been integrated into one silicon. And instead we're talking cellular connectivity, we have graphical expandants, we have a PC software external, you have safety controller integrated and intelligent drives. And in this picture, this is the C30 OmniCore controller, which is a modular design from a hardware modularity point of view. And in the background, you can see that there is going to be a lot more variants coming forward. And the RobotWare software is a pretty flexible piece of software where you both have advanced robot control, very advanced IO system. You have, as I already hinted, integrated safety with support for safety field buses. There is a programming language called Rapid, and then there's a lot of connectivity to other systems, both IoT and industrial. And now lately, this cloud connectivity with cellular connectivity, etc. So very flexible, everything sounds great, right? So why would we want to refactor this device? Well, there is some issues also. So we did this modularity investigation and looked at customer values. And some of the highest ranking customer values that basically our customers valued highest for choosing an AV robot was the ones on the left-hand side. And the problem was that in some cases, they rather lived with problems instead of upgrading the software, because there could be side effects in upgrading the software. The motion performance of the robot would actually be affected if you upgrade it. Also, it took a pretty long time to get your features. And if you weren't a German car manufacturer in the Munich area, you basically had to wait forever to get your features in there, because the response time was long. As goes for bug fixes. Then the software also came in one size. It actually, all software assumed that it was the controller had one footprint, and if we scale down the software, scale down the hardware to fit in a smaller box, the software still assumes that it's in this large box with all these different features that was available for the large system. And then lastly, it simply was a very, very time-consuming thing to upgrade the software in the robot. Specifically, if you have thousands of that you can imagine in these large electronics factories, you need to do this in a more clever way. So there was also a need, if you looked at internally from ABB perspective. I mean, even ABB realized that the release cycles was too long. Also, there was too much labor in testing. Since there was a monolithic distribution, the bug fixing was slow. It was also pretty hard to outsource software development, because you had to integrate that into the software. And the same thing goes for integrating open source or COTS, also very time consuming to fit that to the architecture. And also already said that the software doesn't really scale well with different hardware. Furthermore, there was pretty tough cybersecurity requirements coming up, specifically around patching, if there was critical problems in the software. And there was a great need we realized that we need to have more agile way of work. So why refactor then? Why not just start from scratch? Well, the thing is, of course, that since 1994, there's an extensive amount of features that is solved in software. So any new control system had a very high bar that needed to cross to be able to put something on the market. So I would say that refactoring was the only option that was viable, but selecting then what parts actually are good and which parts would need to be refurbished was the important part. So what did we do then? Step one was to look at software modularization. Can we break the software apart in a more clever way? And with the help of modular management, ABB started to look at this. So modular management is a firm that is located worldwide, but this has its main base in Stockholm. It has a theory from science where the fundamentals of how to modularize was looked at in 1996, and it has helped a lot of companies to modularize in the past. And the modular management is really about helping companies to succeed in doing a business motivated modularity. So as you probably all aware, software can be modularized and sliced and diced pretty much any way. But the interesting part with the modular management approach is that they try to look in 3 different angles. So do you have an operational excellence which makes it possible for you to have a cost-efficient solution? Do you have a product leadership which would give you a price premium on the market? And do you have a customer intimacy that basically makes it possible for you to take the market? So whatever requirements the market throws at you, are you able to address those? And then you come to the question, what is a module? I think, well, most people think that, well, sure, function, that's pretty easy. It's a functional building block with an interface. And then usually it's full stop. But the difference is that it's also connected to a strategy. So what modular management is saying is that you connect this to a business strategy, and then the module has a reason to live, and it's business motivated. And this is a pretty different thing compared to previous approaches that we made in ABB, where we only looked at modularization from a technology point of view. So we as engineers wanted to modularize and make it easier to work, but that wasn't necessarily appreciated by management, because we need to remember that management usually are not software, are not coming from the software perspective. They usually come from a totally different angle. So modular management had this process they call the modular function deployment, where you look at the customer requirements, you identify functions and solutions, and then you propose the modules and interfaces and create variants according to that, so that you have an architecture feasibility. So I put some links here so you can read up more. I will not go into the details here around this methodology. But the interesting part is that you can get some very different outcomes from this process than what you would have if you only looked at technology. So this process has a sweet spot in the logical view and physical view. If you look at this 4+1 architectural view, so you get a very good idea of how you logically should place stuff and how it's connected to the physical hardware. And that makes a lot of sense, given that in this case, ABB was also doing hardware modularization projects. So there was a lot of things happening here in the physical view, whereas in the deployment view or process view, that's where ABB knowledge came in. I mean, that's where we needed to look at that, and of course some tweaks needed to be made to the modularization just due to that. So an example then of what could happen, and so you look at different market segments, and I've obfuscated here the segments and I'll give that away to competitors, but there's a segmentation from ABB, and then that gives these customer values, and that could, for example, be this high reliability, easy to program, could it be low price, and then you connect that to the different properties of the product, and that could be things that you can quantify, like speed, payload, different technologies, etc. And then you set goal values for these different things. So if it's 100 to 300 degrees per second in speed, or if it's 0.5 to 1,000 kilo in payload, or if you need to have accuracies between 0.01 or 0.1 millimeter, and you then map those goal values to the different technical solutions that you use to achieve these properties. the amount of variance you had in the technical solutions and how stable they are give an indication to how you should modularize it. But that is not all. Then you also apply module drivers. So you look at, are there planned development in this place? Do we already have a project looking at improving this? Do we want to strategically buy this piece of software from somewhere else? Let's say an operating system, that's typically not something that AV would buy. So you would like a separation there. Is there a very high technology push on the solution? Let's say cellular connectivity. Is there things happening there? Yes, it's evolving. Cloud connectivity. A lot of things happening in cloud, of course. And when you think of an industrial product like an AV robot, it's going to be on the market for, let's say, 10, 20 years. So you need to plan ahead to be able to modularize this in a clever way so that you don't end up in that you can't upgrade the software. Given all of that, in the end, do you get strategic modules that then have this, that goes according to the arrow picture I showed you previously. So you have modules that either go towards operational excellence, and those you typically want to have very few of. Then you could have modules that go for customer intimacy, and those you can have a lot of because you want to have a good customer coverage. You want to be able to give them all the variants they need to solve their problems. And then lastly, if you have something where you think you are best in the class, and ABB usually say that, you know, we have the best motion control. That of course can be debated, but at least that's what ABB think is the price premium that they have on the market, etc. I said that you want to look at all the features. So what we also did was that we looked at the entire epic cycle for an AV robot controller, starting with how you actually sell it, produce it, install the software, program this device, including setting up I/O, etc. And then running the production, which is like 99% of the time the robot should be active. As well as maintenance, how do you upgrade, how do you give service? And then lastly, also what has been, we have forgotten a long time, is also decommissioning. Is there a second life for this product? Is this a robot that will be shipped to somewhere else? Or do we need to erase stuff here for just privacy reasons in the robot, etc.? So when we did all of this, we looked at 22 different customer values, 138 features, and I can just give an example. Motion control, moving the robot from point 1 to point B, that's one feature. So 137 other things a robot machine is doing without moving the robot. So that's something to think about. Just doing motion control is not what robotics is about if you look at industrial use cases. It's a lot more. That generated 138 different product properties and 400 technical solutions. I think that's pretty large module system. In the end, we generated 32 modules and 107 module variants. So this was the outcome of MFD. Now I obfuscated the module names here for you guys. What we did was that we looked then at really the feasibility of the implementation. A lot of the modules are in the robot applications. So in the end, we got a solution where we could segment the modules according to different needs. So there's a platform. There are modules that are about real-time control and real-time communication. And then we have a separation towards communication and different other configuration tools. But most importantly in this picture is that we have separated all the robot applications to their own space so that they could be having their own release schedule. Yes. And then also, which is pretty interesting, is the modularization approach. So if you look at the entire software, it's millions of lines of code. So how do you start? Well, start from the top and the bottom, because that's where the biggest business impacts are. So getting this hardware separation so that you could innovate faster with new hardware, as well as getting a separation on the user interfaces and external APIs, because that's really where you see the biggest technology push. If you start there, a lot has been gained and a lot of business value has been generated. And then you continue like that, from the top and the bottom, so that you, in the end, the legacy parts are really small. That has other benefits, of course, that you don't break the build dependencies, because that could be hurtful. What the Omnicore controller has that the previous generations don't have is that it has a separation of the applications. So there's an operating system, there's a basic, like a robot control is this platform that actually does the robot application. And then you have the support for different robot arms, and then you put the different applications on top there, as well as provide tools to make a customer or integrator that they can actually do their application themselves. And examples of applications are this, so that we are on the same page. So you have the traditional ones, including collaborative. And then separation here so that they can be accelerated to release customer values without affecting the platform. So great. Modularization then. Great news. Is that all? No. To be knowing that you actually refactor without causing a mess, we also looked at testing. So ABB have something called time test. And the problem statement is like this: can we shorten the test period? So a bug that you introduce during testing will be detected a lot longer in the future, like 2 months later. And I think in many cases, if you are given a bug 2 months later, I mean, in some cases, you don't even know that you were the one that wrote that code. I mean, that's so long. So that also means that solving it is time consuming. But it could also be worse. It could just be a side effect. So you actually don't know what the bug is. It's just a side effect of another implementation. So dying test is about fully automating the testing procedure during RobotWare development. And it should start every night automatically and select relevant use cases using machine learning technology. So depending on what you changed, the software will do a different test scenario. And if you have tested a lot of machines in Sweden, it will test to test the machines in India next time to see if there's a difference in location or testing the same thing. And it will also try to test things at different points in time. So there's no reason to, so that you don't always test certain test case at 12 o'clock in the night. You test the same thing at different hours so that you don't get side effects from that too. So this is used across the globe in all ABB development offices, and then test results are readily available in the morning. So what's the benefit? Well, previously you had this long development period and then lots of manual testing in the end with this error correction. And if we can do this done more dynamically, you save a lot of time and also improve the quality. And also, if you look at the 24 development life cycle, so if the developers start at 9 o'clock in the morning, they start to check in code. And then at 6 o'clock, the build is started. And then typically the build takes a while. And then in the morning, 9 o'clock again, you inspect the build. So that gives you 6 to 10 hours of development, but it leaves you 14 to 16 hours available for build and testing. And since the build takes 6 hours, you have 8 to 10 hours available for testing. So what has been implemented or is being implemented at robotics is that you have this automatic build that gives you response already in 3 minutes. If that passes, we do an automatic subsystem test of the modules, and that should be completed within 6 hours. And then we integrate that on hardware. So within 24 hours, you should be able to get a result on the code you checked in on a real machine in different settings also. And to give you a confidence when you refactor that you actually don't make a bigger mess than you did when you had before you refactor. And of course, there's a lot of money to be earned here doing this better. Then ABB also looked at how to change the way of developing code. So with these monolithic releases, releasing is pretty hard and you don't want to do it so often. But if you modularize this so that when you do a change, let's say you want to introduce this new robot arm, you only change the module that is related to the robotics arm. You don't need to change everything else. Then you can release a lot easier and more often. And this waterfall of doing things is really, the problem is, of course, that you spend so much time in requirements that when you actually done the design and verification, the requirements has changed. This is typically the case. And that makes nobody happy. So what ABB has looked at is implementing this scaled agile framework. And it's an agile development framework that has been taken forth to cope with industry. And it scales so that you can have one or several agile release trains. So the idea is that you have this prioritized backlog. You create an increment backlog that's supposed to cover 10 weeks. And then the teams then pull from this backlog into their own planning and then iterate so that you have a result every second week. And within every second week, you should be able to do a release on demand. That's the approach. To make development faster and also make it more easy to change the prioritized backlog. So that if a real need of a strong customer comes in, you're able to prioritize that over other things that does not have the same value. So the key learnings that we have had from this experience is, start early. ABB started with hardware modularization. And if they would have started with software modularization instead, the hardware modularization would have been so much easier. This starting from the top and the bottom was really a success. You have both an easier journey and you have a great impact on the business very fast, which is important because software modularity is most software developers know all about that, but the business incentive really has to be there to give you the courage to continue doing that, because there will be customers wanting to have features, and usually features have higher priority. Respecting the build order, that's all about you don't pull out modules in the middle of your software if you do this refactoring. Then you will get hurt by circular dependencies. And of course, this focus on automated testing so that you can refactor with confidence so that you don't make a larger mess than you had before you started. That's very essential. In a work like AV has done, change management and DevOps is critical. So make sure that you have those resources up front. I mean, coders are great, but they will talk with CM and CM responsibles to get guidance on how to build the modules. Specifically, if you were going to do a lot of refactoring and shuffle code around, that's the big thing you're doing. In robotics, we also took the opportunity to move to Git when we did this, where there previously was on the TFS CM system. So a separation of safety critical parts also recommended, but specifically safety, because safety has a very different process. This idea of looking at the entire lifetime was great, and that gave us some good ideas on the modularization that we probably would not have had otherwise. And then lastly, the MFD process helped out with this business motivation to do software refactoring. Only do this from technology point of view, I would say will eventually fail. I have experienced 2 major software modularization projects, and as soon as the market turned around, the first thing they canceled was software modularization back in 2008, 2009. If you have a business incentive that there's actually money to be gained, you will be given the time to do this. So, summary, software modularization will give us a better idea of anticipating change, make it able to update mission critical parts easily, and also do software updates over there. Continuous deployment and testing, improve quality and better customer feedback. And in the end, that will give us a better customer satisfaction. And then the agile development, scaled agile framework, and a method to be faster to market responses and give the customer a faster response and a better answer. So that was my presentation. I think I have a few minutes left if there are questions.